The troposphere is the lowest level of the atmosphere, but the next layer is the stratosphere. Now, what's going on here? This graphic right here shows you altitude on the y-axis and temperature on the x-axis. So what you're seeing here is that as you go higher, the temperature is dropping when you're in the troposphere, and then all of a sudden it starts increasing while you're in the stratosphere. So what's going on? Well, in fact, that's how you define where the stratosphere starts, is where the temperature starts increasing with altitude. Now, what's happening is that the air is really thin here. And so ultraviolet light from the sun will actually hit the atmosphere and it'll tend to break apart the oxygen in the atmosphere. So oxygen is normally O2. Well, you break it apart, you have just two individual oxygen atoms. Oxygen doesn't like to be like that. Oxygen likes to be with something else. It's very, very reactive. In fact, very, very corrosive because it's so reactive. It'll react with all kinds of things. And so what will happen is that it will, if there's nothing else to interact with, it'll just find another oxygen and make O3. O3 is 3 oxygen atoms stuck together. That molecule is called ozone. So ozone naturally forms in the stratosphere. And the thing about ozone is ozone absorbs ultraviolet light. So solar UV is being absorbed by the ozone. Well, obviously you're making this ozone all the way through the stratosphere, and so the top of the stratosphere is going to be absorbing some UV, which means there's less UV reaching the bottom. So the top of the stratosphere is going to be warmed more than the bottom, and so that means that the higher you go, the higher the temperature is. So it starts at about the top of the troposphere, so that's between 7 and 15 kilometers up, and then it goes all the way up to about 50 kilometers. In the range of about 15 to 35 kilometers is the so-called ozone layer that a lot of people talk about in the atmosphere. This ozone layer, it's really not a layer, it is like a big chunk of the stratosphere. That ozone layer, the ozone that's in that layer is what's really absorbing most of the UV light from the sun. Now that's important because the sun produces an enormous amount of UV light. The sun's really bright. And so all that UV would actually produce a lethal dose of UV at the surface of the planet. UV is actually toxic. You kill things with UV. That's one way of sterilizing things is ultraviolet light. And so this UV would actually produce a lethal dose. You would actually receive a fatal dose of UV in less than half an hour on the surface of the Earth if it were not for the stratosphere and the ozone in that layer. Okay, so the UV light from the sun is absorbed by the ozone and doesn't make it all the way to the ground. Okay, now the amount of ozone that's up there varies over time. And so what happens is that it gets thicker and it gets thinner, okay, over time. You know, during part of the year, then you're producing more of it. During part of the year, it's dissipating. And so, so over the course of time, you get more or less. Now, the thing about this is, though, that the terminology sounds weird. We talk about a thinning of the ozone layer, or it gets thicker or thinner. And really what's happening is that we are imagining if you take all that ozone and you squeeze it down to a liquid, how deep would it be? And that's kind of a silly way of talking about it, but that's how it's typically done. And so that's how we define thick or thin. Really, it's thinning out or getting, it's getting less dense or more dense is what's really happening with it. Now, Why do we care about all that? Well, because if you have less ozone in the stratosphere, more UV makes it to the ground. We had in much of the 20th century, there were certain chemicals that humans used, chlorofluorocarbons, that were very toxic to the ozone layer. In fact, these things would get up there and interfere with the ozone and degrade it, and it let more UV through. And this was actually been tied to increase in skin cancer. Simply because we have more UV coming through to the ground. It turns out it was more prominent over the southern part of the world than the northern part, even though we actually produce more of the CFCs in the northern part. But that was we'll talk more about the human interaction with the atmosphere later. Convection does not translate into the stratosphere. So when we talked about the troposphere, we said the sunlight would come through, heat the ground, the air would rise. Okay, well, it's rising because the higher it goes, the more it expands and the cooler it gets. But if it's still cooler, or rather if it's still warmer than the air around it, it keeps rising. You know, every now and then you'll have these things, and they'll just get taller and taller and taller, and you get these thunderstorms or these thunderclouds that are miles high, and they tend to be flat on top because that's where you run into the stratosphere, and then it quits rising at that point, kind of spreads out. Now, when you build something this tall, then what happens is that you can get droplets up here. Gravity brings the droplets down, and they get bigger and bigger as they fall, and you can get a thunderstorm. Now, sometimes you may hear in the weather about a cap. What's a cap? Well, a cap is a layer of warm air that's up above you. And so what would happen is, if there's a cap up here, a layer of warm air, then the convection is rising. When it hits that warm air, it quits rising and flattens out, and it does not build into the thunderstorm. So you know, in the summertime, when they're saying there's a cap over the DFW area, so we're not going to likely get thunderstorms, that's what they're talking about. They're talking about a layer of warmer air that's aloft. So here's an example. Here's some pictures off in the distance of these big thunderstorms and the flat anvil type tops that mark the boundary between the troposphere and the stratosphere. And again, there's another one right here. And so that's the boundary.